Good morning, Earth Science class. We are separated from coronavirus and from each other. So I'm going to try to do a presentation through Google Hangouts and record it and send it to you in Classroom. So we'll see how this goes. It might be a little rough, but hopefully you can see my screen. So at the end of this lecture, there's going to be some summary questions, just a little exit ticket on Classroom that you can fill out, and that will serve as our notes. But we're learning about climate, and climate is the long-term weather pattern of an area. So one example of a climate would be a tropical rainforest. Another would be a tundra. So these are areas that get a certain type of weather, and we can predict the sort of weather they're going to get. And so to start out, we're going to look at some Google Earth, and we're going to look at some different places and see if we can make some connections about why they look the way they do. So here's the first one. I grew up in Washington. You can see from Google Earth that everything over here in the west is green and lush, and everything over here looks dry. I mean, there's definitely some green, but in central Washington, it's mostly dry. And in the middle here, we have some mountains. So we'll notice the same thing in our area. There's the Bitterroot Range near Missoula, and here's us. Here's the Rocky Mountains, and here's Flathead Lake. So we have lush green, and then we have a lot of brown. And so both of these areas are grasslands, and something must be causing that difference. Some of you know already, but we'll figure it out. Okay, here's another one. If we go down here pretty close to the equator, we have this really lush area. This is the Amazon rainforest. And let me see if I can remember how to do a grid. Yep, so right along the equator, we have the Amazon rainforest. What do you expect is on other parts of the equator? Another rainforest. This is the Congo rainforest. And over here, we have Indonesia, another rainforest. So not a coincidence. If we go up to the Tropic of Cancer here, we find the Arabian Desert. We find the Saharan Desert. We find Mexico, which has a little higher elevation, has some mountains, so that changes things a little bit. But if we go south to the Tropic of Capricorn, we have a desert, and we have Australia, which is all desert. So kind of some interesting connections. There must be something going on. There must be some pattern that makes these climates. And you can probably notice some other interesting things too. Let me take that grid off. There's the Himalayan mountains here, and so we have a bunch of green, and then we have brown. So the connections we see across the world can probably be explained by the same phenomena, and that's climate. So here's one explanation. When we looked at Washington State and we looked at Montana, we see evidence of orographic lifting. So oro in Spanish means mountain, and usually we have warm air from a body of water that's coming and it hits the mountains. And we know that when there's warm air, it's expanded. When that hits mountains and it rises, it condenses, actually it expands and cools. And then as it cools, it condenses again and it forms clouds. And then it condenses so much that it rains. And then as that air ends up on the other side of the mountain, that expanded cool air ends up compressing. And as it compresses, it gets tighter and warmer and warmer and warmer. And so it's dry air over here. And so we also know that rising air means low pressure, which means it can make clouds. Sinking air means high pressure and sunshine. So that explains why the western side of Washington is wet and lush. The east side is dry. And for us, our side of the Rocky Mountains, the western side, is wet and lush. Great Falls, Browning, those are dry, and they usually get a lot more wind. That's from orographic lifting. Same thing happened in the Himalayas when we looked at that. It's coming, instead of coming from the west, it's coming from the south over India. Then it hits the Himalayas and rains, and on the other side, it's dry. So this side's called the windward side. This one's called the leeward side. Something else we notice is differences by latitude. And so remember that a season is because the Earth is tilted. And so in summer, the northern hemisphere is tilted towards the sun, which means it gets a lot of light up here in the North Pole because it's exposed all day. And then these areas get more light, which is why the sun's higher in the sky and why it's warmer for us. It's opposite for winter. We're facing away, and so we get less direct sunlight. The North Pole would get 0 daylight for a few days a year. And so remember when we looked at the deserts are right on this line, the Tropic of Cancer. Direct sunlight, even more direct than the equator. And so these areas get so much sunlight that they have no chance of creating precipitation. And so we find our deserts there. And same thing for the south. Remember, we found Australia on this line, and South Africa was on this line too. So that's a high pressure system. They get a lot of sunshine. And then here, the equator, no matter which picture you look at, the equator is getting a good amount of sun, and there's a lot of ocean on the equator, so that water evaporates, forms clouds, and then ends up condensing and forming rain clouds and raining. And so most of our tropical rainforests are along the equator. Here's something else you've probably heard about in the news, the greenhouse effect. And so if you think about being in a greenhouse, it's really humid and warm in there. That's because those gases are trapped and the sun hits them and heats them up. So our Earth is like that. And this is a good thing because since we have an atmosphere, the solar radiation comes and it heats up the molecules in the air. And then it actually doesn't escape very easily. We retain our heat. So think about sometimes on a cloudy winter day, you wake up and it's still pretty warm. And those clouds are like a blanket heating up the Earth. So this is why Earth is livable and Mars is not, right now at least, because Mars has a thin atmosphere and it can't retain heat. The moon has like almost no atmosphere and it can't retain heat at all. So this is a good thing unless there's too many greenhouse gases. So CO2, that's carbon dioxide, and nitrous oxide and methane. So methane you've heard about, that comes from cows belching, and this comes from CO2. From burning fossil fuels, we breathe it out, animals breathe it out. And also H2O should be on there too. So water vapor increases the heat in the atmosphere, methane increases the heat, and CO2 increases the heat just because they can absorb the actual energy and then maintain it. And so if we're increasing the amount of CO2 in the atmosphere, then we might be increasing the heat. So if we look at this map, this is measuring world precipitation. We're going to see some of the same patterns that we saw before. So remember, along the equator, we said we'd find rainforests. And so sure enough, all of the dark blue and light blue are close to the equator, maybe a little north or south, but definitely centered around the equator. And then we should find deserts, which means the least amount of precipitation around the Tropic of Cancer, like this, and the Tropic of Capricorn. Now, it's not always true, right? Because we can have orographic lifting that changes things in different ocean currents and temperatures, which we'll talk about in a second. But those are two good patterns to remember. Equator means rainforests. The tropics, Tropic of Cancer and Tropic of Capricorn, mean low precipitation. And we notice some other things too. So this area gets a lot of moisture, and that is from the wind coming from the Atlantic and from the Gulf. Here too, we have winds coming from the Indian Ocean. We have a lot of deserts that are higher up. And notice that the North Pole is actually a desert. So it's a polar high up there, air is descending, and so there's no way to make clouds. And same for Siberia over here as well. Some of these deserts are from orographic lifting. So remember, the windward side is going to get the rain, and the leeward side gets the descending warm air, which means no precipitation. So that explains this part of the United States. It explains this part. There's the Himalayas here. And so it's called a rain shadow when we have the mountains that block the rain on the leeward side. So they categorize these zones, these climates, into these words. So tropical, this would be tropical rainforest. We also have tropical savannas, which means that they have seasons of dryness, but they have crazy rains too when it's the rainy season. And then we have a monsoon, which is what we typically talk about in Asia here. So especially India, they have really heavy seasonal rains. And if we look down here in central Mexico, Central America and southern Mexico, they get a lot of rain from the warm ocean, and because they have mountains here. And so those mountains end up making a lot of rain. This area in like Western Washington and Oregon and southeastern US is called mesothermal. And so like the marine West Coast, that would include Seattle. So they actually have some temperate rainforest, meaning it's not warm, but they get a lot of rain. And then you see this in the Mediterranean too. So these would be typical experience multiple seasons, but probably a mild winter. And microthermal means really cold winter. You might be surprised that we're not in this zone, but these are areas that have really harsh winters, mostly like this part of the northeastern United States. They get a lot of cold air from the Arctic, and so that's why they're included in this. And you won't be surprised that northern Russia and this northeast part of Europe is in that category too. We are actually in the highland because we are at altitude. And so we obviously have 4 seasons. We can have extreme winters, but a lot of that is because we're at 3,000 feet, and that's a lot higher. Seattle's at 0. So we have a lot bigger effect because of our altitude. And then the last one that's important for us is the desert. And obviously that means it's arid. It does not get a lot of rain. And we've experienced that in the 4 corner states here and in Montana, North Dakota, not a lot of rain. So keep in mind, we talked about this earlier, that this is because the equator is low pressure down here. So air's rising, and then it cools and creates storms, and then it ends up coming down at the tropics, and that's the high pressure that eliminates any chance of rain. So we talked about air masses too, and notice that now you can see that these air masses are going to interact with other air masses around them. So if we have this maritime tropical, it's going to collide with this polar and cause rain. This maritime polar is going to cause certain weather for that. And so you can see what the climate is going to be just based on the air masses around it. So if this is continental tropical, well, it's hot, but it's really dry. And so there's not much chance of rain there. This is really hot air, but it's very moist. And so there's a good chance that this is going to get a lot of rain. Equatorial is very moist. So that could increase the rain even more than this maritime tropical. One thing we haven't talked about much is the ocean currents. And so keep in mind that all storms are going to be generated from the water being evaporated. So we did, as we talked about hurricanes, we have warm Atlantic Ocean and Gulf Ocean coming up along the coast. So all of that can evaporate and then cool and condense and form clouds and make storms. This cold ocean current on the West Coast, it doesn't evaporate as easily, and it doesn't cool and condense and make big storms. So obviously Seattle gets some storms, but Seattle's getting this warm current from Asia. And so Seattle and Oregon get that rain in Northern California, but Southern California, there's like water from deep in the ocean that comes up. And so it's really cold, and it doesn't create a lot of clouds, which is why most of Southern California is a desert. So we have this too. We're going to see, as I talk about climate change, that typically there's a cold, deep current that comes up the South American coast, and then it heats up as it hits the equator, and then gives Australia kind of the warm ocean current that it is used to. So this current in Peru, it does not make a lot of storms. So it's pretty dry here, and there's huge mountains too. So it's dry and there's huge mountains, but there's not a lot of rain because there just isn't a lot of evaporation. Whereas this side, we have the Amazon rainforest and we have a warm current. So you can see how warm water is going to feed rain. Cool water is going to feed a dry climate. And so we end up putting all of these together to combine and form our weather system. So let me see if I can find that that picture. That wasn't it. Okay, so this picture is really complicated, but it kind of tries to put all of this together. We have the humid subtropical, we've got this maritime tropical air mass, we have warm ocean current, and all of that combines to make this climate right here. And you can see the same over here, that we have a temperate rainforest here, and that's from maritime polar air masses, plus some warm and cool currents that combine to make that rain. We have our highland climate here too. And again, it's just kind of tries to include all this stuff. One thing that we didn't talk about yet is that convergence zone at the equator that causes so much clouds, that moves. And so in July, it's up here, and it moves because, remember, the tilt of the Earth moves. And so if it's tilted more towards the sun, then you get one type. And so this creates more rain in July along this line, but in January, there's more rain along this line. Okay, so you're going to answer those questions in Google Classroom and see how much you learned. And I hope you guys are having a good time at home, and I'll hopefully see you soon. Bye.